The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Good morning, good afternoon, and good evening, everyone. I love seeing this engaging video advertising the AI for Good Global Summit, so mark your calendars. It's been a great experience last year, and I'm sure it'll be this year as well. In the meantime, we have amazing content here in the Discovery channel on health topics. And it is my pleasure to welcome Avi Goldfarb today, speaking on the disruptive economics of AI in healthcare. So Avi received his PhD in economics from Northwestern University, and he's currently the Rotman Chair in Artificial Intelligence in Healthcare and Professor of Marketing at the Rotman School of Management at the University of Toronto. And I think it is really a rare combination of hearing someone speak with expertise in both economics and health. As someone coming from medicine, I'm currently training in internal medicine in Berlin, Germany. Often in interventions, we don't really look at the economic sides of it. And Avi is really someone who has spearheaded research into all the different dimensions in marketing, computing, law, management, medicine, and many more disciplines. You can read many of his articles, but also 2 books that he's written. They're called Prediction Machines and Power and Prediction, which cover different topics on the economics of AI. Dear audience, you're logged into the neural network. You can ask your questions in the chat wall. Please ask short questions and many. We'll have plenty of time to discuss. And Avi and I will log into the neural network after the talk to continue discussing with you. All right, Avi, please take it from here.
Hey, thank you. Welcome, everybody. It's a pleasure to be part of this. I'm just going to get my slides up on screen. Okay. So as Matthias mentioned, I'm a University of Toronto professor. I'm an economist by training, and I sit in the marketing department. Before I even arrived at the University of Toronto, I arrived here in 2002. Before I arrived at the University of Toronto, our computer science department had hired a few people, most notably Jeff Hinton, who was trying to build algorithms that mimicked the way we thought the brain worked at the time he was doing his research in the 1980s. And he made progress developing those algorithms, and it became, a part of computer science. These neural net. It was still very much basic science and not really impacting the world at scale. He, over the years in the early 2000s, he started to have junior professors and postdocs and graduate students all working on this technology with him. And it was still very much deep science locked in the university. And then in 2012, Hinton and a team of his graduate students entered Fei-Fei Li's ImageNet competition. And
Harvey, just very quickly, sorry, are you scrolling? Do you need to scroll, or are you...
I am not scrolling.
Oh, okay, apologies.
Okay. But I will within a minute, and if it's not scrolling, then let me know. They entered Fei-Fei Li's ImageNet competition, and they won. And they didn't just win by a little bit, but they used their algorithms to predict the label of an image and beat the competition by so much that by the 2013 competition, almost all of the leading entries were using some version of the algorithm submitted by the University of Toronto folks. And so that the future heads of AI research at Meta, at Apple, and at OpenAI, 20 years ago, they were sitting 2 blocks away from me at the University of Toronto. Now, that's, many of you are in great universities, and in great universities around the world, exciting stuff happens in departments all the time. This is par for the course for those of us who work in academia. And what happens is we receive an email or something from saying, hey, there's exciting stuff happening in the computer science department. So there would have been an email in the bulletin. I would have opened it, like most faculty, read it, and said, oh, look at that. I am proud to be part of the University of Toronto where exciting stuff is happening. And then, well, look, I'm in the business school. That's not my research area. And I, turn around and go about my regular research and completely forget about the exciting stuff happening in the university. But what's different is my co-authors and I, Jay Joshua and I, we run this organization called the Creative Destruction Lab. And the Creative Destruction Lab is a program that's helped science-based startups scale. We're now in 13 universities around the world. And the essence of that program is to see the deep science happening locally and around the world and try to turn that into companies. And when we started the lab way back in 2012, there was a company out of Hinton's lab called Atomwise, or at least out of our computer science department. And Atomwise was using artificial intelligence to predict which molecules bind with which proteins. They're using AI for drug discovery. And 11 years ago, that just seemed crazy. And so Jay Joshua and I were fascinated by the one company, but it was one company, it didn't seem to be that much. Over the next few years, this trickle of AI companies became a flood. So that by 2015, 2016, we had so many AI companies applying to our lab that we doubled the size of the lab and had, as far as we know, the first accelerator with an AI-focused cohort. At that point, it was clear that with our academic hats on, with our professor hats on, we'd made our careers focused on understanding the economics of the internet. And it was time to try to get our heads around this new technology, the economics of AI. That led to our first book, Prediction Machines, which took the combination of our insights and our points of view as economists focused on the economics of technology, combined it with, by that point, the advice we'd given to hundreds of AI startups as they tried to scale. In the last year and a half, the excitement and hype around AI has exploded. ChatGPT came out November 30th, 2022. And since then, we've moved from this is an exciting technology that Silicon Valley is paying attention to this is a transformative technology, everybody, because they can interact with that user interface of ChatGPT and DALL-E and the other tools. So that we moved from this is something that the tech company should be paying attention to this is something that might be a multi-trillion-dollar industry that could change computing culture. And AI is going to take over the world. In medicine in particular, there is both excitement and anxiety about hype. We hear that potentially AI is medicine's biggest moment since antibiotics. There's a increasing research on how AI is going to impact healthcare from an economic point of view and from a medical point of view. And there are worries about how AI might help management, but hurt medical professionals, or maybe even make medical practice worse. Daniel Kahneman is the only psychologist to win the Nobel Prize in economics, has framed the challenge as clearly AI is going to win. How people adjust is a fascinating problem. It's a fascinating problem if you've already won the Nobel Prize. For most of us, however, it's not a fascinating problem. It's a terrifying problem, right? If the AI is going to win, what does that mean for us humans in terms of our work? What does it mean in terms of the quality of care, in particular, that we're going to get globally through health? Underlying the excitement and the confusion is the big question about what we're talking about when we're talking about artificial intelligence. If you believe the hype and the press, there's a sense that we're on the verge, optimistically, of the Jetsons. Have machines that can do just about everything we can do, and they listen to us. Or, more pessimistically, we're on the verge of Skynet or the Matrix, where we have machines that can do just about everything we can do, and we don't listen to us. It's important to recognize in the background that idea of truly intelligent machines it's not crazy. There's a reason why Kahneman said clearly AI is going to win. But there's a big question about when that's going to happen. And when we look at the technologies we have today, the technologies we have today are not truly intelligent machines that can do everything we can do. There's something much narrower, which is prediction technology. What's happened, today's AI is not intelligence in the general sense. It's computational statistics. It's using information you have to generate information you don't have. It's prediction in the statistical sense. And so when you hear AI today, you should think about it as a drop in the cost of prediction. Prediction, computational stats, has gotten better, faster, and cheaper. Now, it's true, we might be a little less excited about it. It might get a little less press. My book might have sold a little bit less had we called it Prediction Machines, the Simple Economics of Computational Statistics. But that is exactly what we have. Computational stats have gotten better, faster, and cheaper. To get a sense of why it's transformative for technology to get better, faster, and cheaper, I'd like to jump back a generation and remember 1995. I can't see the age of the folks on the call. Many of you may remember 1995. For some of you, it might seem like ancient history. So let me give you a framing of what the world was like back then. It was a very exciting year in technology. It was the year that in the US, the last aspects of the public internet, the NSFnet, were privatized. It was the year that Bill Gates wrote his internet tidal wave email and said to the folks at Microsoft that the internet was going to be the future of Microsoft and therefore the future of the software industry. It was the year that Netflix had their IPO, and they were valued at over $1 billion without a nickel in profit. And so the hype around the internet kept building to a point where by 1998, people were not talking about the internet like a new technology. They were starting to call it a new economy. They said things like, we no longer need our economics courses. You no longer need to understand the basics of supply and demand. Throw out your economics textbooks. The world has changed. Now, there was one group of people who said quite aggressively, you still need to take your economics courses, and you still need to read your economics textbooks. And that was, of course, that was us. That was the economists. Now, why do we say that? Partly, admittedly, it was self-interested. But because once you understand the economics of the technological change, you can forecast a lot of the transformations that are to come. So, for example, what the internet meant was cheap search cheap communication, and cheap copying. And once you understood that, you could map out various consequences. So once it was cheap to replicate information, to copy it, some things were obvious by 1998. Copyright was going to be a very big deal, and we needed to figure out ways to appropriately protect intellectual property. That was going to be transformative, and we saw that happen. But other things might have been less obvious unless you thought deeply about what cheap copying meant. Once you realize that anything you say to anyone around the world, once anything you say to anyone can be instantly broadcast around the world for free, you're going to be more careful about what you say. Cheap copying meant privacy was going to be a much bigger deal. And that was clear to the economists who were thinking deeply about what the transformation of the internet meant. By the way, led by the dominant textbook writer of the 1980s and 1990s, a man named Hal Varian. So he had a book called Information Rules, which mapped out those changes to the economy. Jumping back another generation, think about your computer. What does your computer really do? Feels like a computer does all sorts of things, but really, your computer only does one thing, just does it really, really, really well. And we're economists, so we represent it as a drop in the cost of something fundamental. Somewhere around 1960, the thing your computer did, arithmetic, became much cheaper. Prior to 1960, if you wanted to do large-scale arithmetic, you needed skilled humans, teams of them. For example, in World War II, and shortly after, there were these cannons, and they shot cannonballs. And it's a really difficult arithmetic problem to figure out where those cannonballs are going to land. And so there were teams of humans whose job was called computer, who calculated these artillery tables. The movie Hidden Figures was about a team of such humans whose job was called computer, who figured out the trajectory of rockets. But increasingly in the 1960s, as machine arithmetic got better, 50s and 60s, those machines started to replace the humans. And we started to have machines doing arithmetic that used to be done by these teams of humans. Similarly, if you ask an accountant who was working in the 1950s, 60s, and well into the 70s, what they spent their time doing, they spent their time adding up columns of numbers. But now, accountants don't really add up columns of numbers anymore. Machines do that for them. Encouragingly, there's still plenty of accountants around, because it turns out the people who were good at machine arithmetic at human arithmetic, were also good at leveraging machine arithmetic to for company strategy and tax policy. So as machine arithmetic got cheaper, something else happened. We started to realize that there's all sorts of applications of arithmetic that were, when arithmetic was expensive because humans did it, weren't feasible. So this was, in some sense, discovered by Charles Babbage and Ada Lovelace and Alan Turing. But it wasn't until machine arithmetic got, in practice, cheap enough that we realized that games and mail and music and pictures, engineering-wise, could be solved with arithmetic. Kodak was a chemical company, fundamentally. Chemical engineering was what they did so well. And as arithmetic got cheaper, we moved from a chemical engineering world into a world where pictures were practically solved through arithmetic. So that gets us to AI. This is a convolutional neural net. This is one of the technologies underlying the current excitement in AI. We should think about it as a drop in the cost of prediction. Same graph, different label on the axis. What's happened over the past decade or so is that prediction has gotten much machine. And as machine prediction gets cheaper, just like with machine arithmetic, we're starting to find new applications and all sorts of applications of machine prediction. We started with good old-fashioned prediction problems. You walk into a bank and you want a loan, and the loan officer at the bank has to predict whether you're going to pay back the loan. They've been doing that predicting whether someone's going to pay back your loan maybe is the oldest prediction problem in business. It goes back thousands of years. It used to depend on whether you trust some gut feel about whether you trusted them, or through connections in your social network, then eventually through collateral, through credit scoring, and now increasingly, the lending industry is using machine learning tools, is using AI, is using prediction machines back a loan. The insurance industry is in the business of pricing risk. They are in the business of prediction. They too are using AI to predict, for example, whether you're going to make a claim on your house and how big that claim is going to be. But as prediction's getting cheaper, we found other applications of machine prediction that we didn't used to think of as prediction problems, like image recognition. We now know that identifying whether a particular image on YouTube is a cat can be solved in prediction. You put the pixels in that image, whether cat is the appropriate label. And especially in the medical context, what's become increasingly clear is that diagnosis is prediction. When you diagnose somebody, you take in data about their symptoms and you fill in the missing information of the cause of those symptoms. That's prediction. What OpenAI is doing and the other generative models are doing is also prediction. We didn't used to think of as writing and drawing, of writing and drawing as prediction, but it turns out writing and drawing are prediction. What is ChatGPT doing when it writes a paragraph in response to a query? It is predicting the set of words that is the most helpful, honest, and harmless response to your query. What is DALL-E doing if you ask it for an astronaut on a horse in the style of Andy Warhol? It is predicting the image that best represents an astronaut on a horse in the style of Andy Warhol. It is not a search engine. It's not that there's a database of images and it's picking the image that best fits what you describe. Instead, there's a database of images of people on horses, images of astronauts, and images that define the style of Andy Warhol. And it is combining those to predict, in a statistical sense, what you're looking for when you ask for an astronaut on a horse in the style of Andy Warhol. And these tools are getting to a point where they are better than most humans at many of the most core intellectual tests that we have for humans. The MCAT, for getting into medical school, the bar exam for becoming a lawyer, and many of these other advanced technologies. So it is no surprise that the underlying hype around AI is people recognizing that Andrew Ng, Stanford computer scientist Andrew Ng's prediction from 5 years ago or so, that AI is the new electricity, seems to be coming true. AI seems to be transforming the way we live and the way we work, just like electricity transformed the way we live and the way we work. How do we think about this now? Because many of you might think, well, the AI is exciting, but it hasn't really transformed medicine in any meaningful way so far. Well, think about it as right now the predictions are good. You have a dial, and right now the predictions are good. And eventually you might turn up that dial and make the predictions better and better and better, transformative. So here's an example of a good prediction. Amazon's recommendation engine. Amazon's recommendation engine is good in the sense that their predictions are something like 5% accurate. There are hundreds of millions of items in Amazon's catalog. And for every 20 items they recommend to you, you're going to buy something like one. That is an extraordinary feat of engineering, and it has been very profitable for Amazon. But it hasn't really been transformative. Recommendations and your user experience, that aspect of it hasn't really changed in 30 years. So imagine, like, flashback to 2003. What would have happened if you went to Amazon? You would have gone to the website. They would have recommended something to you. They would have recommended the same thing to every one of you, which would have been the Da Vinci Code. That was the most popular book on Amazon. Everybody would get the same recommendation. Then, if you choose to buy that or not, whatever you chose to buy, they send that information to a warehouse and they ship it to your door. That's exactly how it works now, with various improvements in the efficiency of the process. The difference being the recommendation is now personalized. But imagine we turn up that dial. So instead of 5% accurate, it's 25% accurate or 75% accurate. At some point, the predictions are going to be good enough that they can do something different. Instead of waiting for you to order, they'll be good enough that they'll just ship it to your door. The predictions, to be clear, don't have to be perfect. They just have to be good enough that it's worth it for them to build an infrastructure to deal with returns. They're going to capture enough share of your wallet that it's worth it. Let me be clear, Amazon hasn't done this. I don't know if they ever will do it. I don't know if it's technically feasible. But I do know that they've thought about it. Here is a patent for anticipatory package shipping from Amazon.com, Amazon Technologies. This is something that is on their radar. But if you look more deeply about this technology, this patent, you'll see something is wrong. In particular, this patent is from over a decade ago. This has been on their radar for a long time. And here we are in 2024, and it hasn't happened yet. Now, broadly, Amazon has had success with their investments in AI. But when you look at adoption and you look at success across the board, the vast majority of sectors across the economy have not adopted. And depending on how you count, healthcare could be a leader or a laggard. This is a study where healthcare is relatively high in terms of adoption. This is US data. But that's because there aren't a lot of very, very small healthcare organizations. Now, but if you look at even the most AI-intensive industries, we have something like 12% of firms adopting. More generally, of that small fraction of firms that have adopted, the vast majority of them say they haven't seen the benefit yet. How does it make sense that most companies haven't adopted and most adopters haven't seen the benefit if AI is going to transform the way we live and the way we work like electricity did? Well, let's dig into the history of electricity a little bit. Edison's patent for the electric light bulb was in 1880. Tesla's patent for the electric motor, 1890. It was clear, if you were paying attention in the 1880s, that electricity would transform how we lived and how we worked. But it wasn't until the 1920s, an entire generation later, that electricity had an impact on most people's lives at home and at work. To understand what took so long, it's worth understanding what a factory might have looked like in the 1880s. In the 1880s, this is an image of what a factory might have looked like. You can see there's a steam engine, a power source at the center of the factory. And every single machine around the factory had to be connected by these belts and shafts to that central power source. And so what happened as people started to electrify is they took out the steam engine, dropped in an electric motor at the exact same point, and doing the benefit of electrification was minimal. It saved 5, 10, 50% maybe on their energy, but it didn't really make much difference to the overall bottom line. And taking out your steam engine and dropping an electric motor was hard. You had to figure out how to get electricity distributed into the factory. You had to figure out, for example, how to lay out your wires in the factory so they didn't cause fires. You had to teach all your employees not to touch those wires so they didn't get electrocuted. There were all these things that had to happen in order to electrify. And if all you were doing is what you always did, it just wasn't worth it. So even though we now see how electricity transformed the way we lived, the way we worked, when electricity was in a way did what people always did, but a little bit better, it wasn't worth the bother. And so in 1900, just 5% of US factories, and the US was the leading country at the time, just 5% of US factories were electrified. But then around 1900, something changed. People started to realize that electricity wasn't just cheap power. Electricity was distributed power. It allowed you to decouple that power source from the machines. It allowed you to invent a factory. The quintessential 20th century factory that you might have imagined being built by Henry Ford and others is a direct result of electrification. They figured out that once you were no longer dependent on those belts being connected to the central power source, you could organize your factory. You could build these huge factories with inputs in one end and outputs out the other to create effective modular production. That was what was so transformative about electrification. And it was then that we saw a change in the trajectory and a rapid increase in adoption. We're in the 1890s. What do I mean by that? We can see the potential of AI, but we haven't figured out what an AI transformed industry looks like. And so what this means is we can feel, we sense, yes, AI is going to transform industry, but we haven't figured out what that industry of the future really looks like. So when we think about this in healthcare, if you do a search for AI in health, or AI in cancer, or AI in any global healthcare challenge, you get hundreds of thousands, if not millions of hits. And yet, for the most part, even in the most AI advanced country in the world, only a fraction of healthcare organizations are doing anything in AI, never mind it being transformative. We have all this work, and it hasn't changed the practice of healthcare in a meaningful way for the most part. How does that make sense? Well, it makes sense because you have to recognize that we are in these between times. We have the potential of technology. We've seen the potential of the technology, but it hasn't transformed the way we live and the way we work yet. Now, what is it that AI does? Let's think through that this fact that machines can diagnose. That didn't do what I thought it would. Let's think through this fact that machines can diagnose. There we go. Now, in the practice of medicine, transformation with diagnosis machines could empower millions of medical professionals around the world. What do I mean by this? Right now, in most healthcare systems, we have this idea that the doctor is at the center of everything. And in particular, around the world, doctors have a legal monopoly, for lack of a better word, on diagnosis. So one of the core things we train doctors to do, and one of the core things that doctors do that other medical professionals, nurses, pharmacists, and others don't, is diagnose. Now, once the machine is diagnosing, many of the things that the primary care doctor does, or many of the things that diagnosis-focused doctors do, can now be done by other medical professionals. And in the US, for example, there are 760,000 physicians and surgeons who earn a median of $200,000 a year and an average of much more. Now, there are 3 million registered nurses in the world who earn a median income of a little more than a third of what those physicians do. There are millions more pharmacists, physician assistants, paramedics, and others. Once those people can be trained to work with machines to diagnose, then they become superpowered. And that can transform global healthcare. There are millions and millions of nurses around the world. There are millions more local medical leaders and professionals who do not have the training of doctors, to do diagnosis well, but combined with the machine, they may be able to diagnose many of the most common maladies that people have just about everywhere in the world. And once you have that diagnosis at scale, well, first, for those things that we already know what the treatments are, and those treatments are easily distributed, we now have massively improved global healthcare. For things that once we're diagnosed at scale, treatments are not available to get to populations around the world, there is a real opportunity for innovation to identify treatments that can be distributed cheaply and easily around the world for those things that are newly diagnosed. So anywhere where diagnosis was the bottleneck to large-scale treatment, when we have prediction machines deployed, we can now do that diagnosis effectively and efficiently at scale. That's what we mean by thinking about this transformation. One last thing to cover, which is how does this play out in any particular context, in any particular industry? How can you sort of work through where the biggest opportunities are? A starting point is to recognize and work through your standard operating procedures and map them. Think of the goal of the organization. So think about what excellence looks like. What does an excellent airport look like? Well, the best airports in the world, Seoul, Incheon, Singapore, Beijing, they are spectacular pieces of architecture, right? They have fantastic shopping, like the fanciest stores in the world, Prada, Gucci, whatever else it might be. They have great restaurants, natural light, greenery, theater, public art. They can be just spectacular places. You'd almost want to hang out there. But almost all of you would rather fly, if you're flying, through an airport like this. This, in particular, is how the billionaires fly. If you have your own jet, you don't get Prada and Gucci. You get this little shed with no stores, with a magazine rack, with the same magazine over and over and over again. How does that make sense? Usually, the people who can afford more get better stuff than the rest of us. But in airports, they get worse. The reason is true. Well, the airport. The mission of Seoul Incheon is to ensure smooth air transportation. The vast majority of what they do is fact they fail. Airports are these monuments to uncertainty. If you knew how long it would take to get to the airport, if you knew how long it would take to get to the airport through security and to the gate, then you wouldn't have to wait. That monument to uncertainty, the Prada and the Gucci and the restaurants and the greenery and the natural light and everything is a monument to the fact that you don't know how long it's going to take to get from home and onto the airplane. And when you eliminate that uncertainty, if you had a prediction machine that could eliminate that uncertainty, so much of the airport's revenue model and so much of the airport's standard operating procedures would have to change. That architecture exists because they fail to deliver what they really should. And so the question for healthcare, and especially in global healthcare, is how much of what you do is about really delivering on the mission, and how much of what you do is because of a failure to deliver on that mission. And then think through how technological change, and especially how prediction machines, how AI can allow you to deliver much, much better on what you're really trying to accomplish. Thank you.
Thank you so much, Avi. That was really provocative and fantastic and interesting. I invite everyone in the audience just to, keep your questions coming. We'll see them here in the chat and we'll pick them up. Avi, the last bit you mentioned really got me thinking about in medicine how much we fail to deliver what our mission is, and it made me really think of, we usually see patients when they come with a disease or diagnoses, they've come a long way of like maybe decades of being, exposed to, I don't know, bad air, pollution, and so on. And I feel like sort of, prevention and prophylactic treatments, they're so important, and it's so hard to deliver those because healthcare is so focused on like the last percent and, the most acute presentations. Do you have any thoughts? Have you thought about it?
So it's really gonna depend on the healthcare context. So much of what within hospitals that look like the hospitals that we have, in Canada and the United States and much of Western Europe, a lot of that is infrastructure to deal with failure. We keep people in the hospital because we just don't know. Okay. And you need people to be in the hospital for their surgery. But then we keep them in the hospital because there's all sorts of uncertainty about what could go wrong. We bring people to the emergency department and not to the rest of the hospital because we don't know what's actually wrong with them. And so much of that infrastructure is really about this, failure to have good prediction. In more generally across the world, a lot of the way healthcare is delivered is because we don't really know what's wrong with somebody, and we don't really know how to get treatment to them. These things together. And so if we have better diagnosis about what's wrong with somebody, then often we can get the treatment to them more effectively and efficiently, or at least figure out if we can or can't. So globally, many of the challenges in care are again about bad prediction. Okay. But like the last piece of that is, especially in terms of global health, we need more invention. So the combination of diagnosis and treatment go hand in hand. There's no point in diagnosing things at scale if we don't have treatments available. So like, for example, there was this company that figured out how to diagnose heart failure in rural Africa. They had a little box, basically a briefcase that you'd go, and it was great. You could diagnose heart failure. But the real barrier to that is, well, you actually need surgery. And so if you don't have enough cardiac surgeons or cardiologists, then who cares if you can now diagnose heart failure at scale? Where other things, if you could diagnose them well at scale, maybe they could be treated with medicine or bed rest or particular foods. And for those, we need more innovation on the treatment side. So you can see these things go hand in hand. Just solving one piece, actually have to rethink the many aspects of the architecture of healthcare.
Yeah. So Nicholas is wondering, how do you see the future of primary care in 10 years? And do you think every primary care physician will be replaced by AI or augmented by an AI?
Okay, so I don't want to give any timeline because a lot of that's regulatory and there's some technological barriers. But let me put it this way. Here is an exciting vision of the future of primary care. Okay. Your primary care medical provider is a human medical professional. No one's getting replaced by AI. But it is a human medical provider who has 4 years of undergrad schooling, not 10 years of post high school. And that allows us to have to overcome many of the issues in the shortage of primary care around the world, and also potentially to have people who are better at helping us manage the stress of the healthcare system. And so right now we have these people called doctors, and doctors are selected on all sorts of things. Yes, they're selected on how caring they are, but it's probably not the primary reason people get into medical school, their social skills. But once we're in a world where the AI is doing diagnosis, we might be able to transform that and change that.
Yeah, and I would agree. I think, you can, there's a lot of challenges in building good machine learning models. And I think even the past years have shown like also the shortcomings in terms of biases and data drift and shift and so on. And that if you place a model into a new context, predictions look much different than, what they've been trained on. Also, I'd be worried in the primary care context if patients would, give like all the information that's needed. So I wonder if that is also one of the risks that, there might be a couple of facts about the history, about, exposures, that if they don't, readily tell it to any model, but probably like the conversational generative AIs of the day could probably help, and turn it into conversation. But I agree, at the end, a specialized nurse or doctor would always need to double check.
So I don't know. Well, we'd always need a nurse or a doctor to double check. I'm skeptical of. I suspect that with time, the machine will be better at many things than the human. And the role, I still think, who knows, but there's still a role for human interaction, but it's not to put a check on the machine. In fact, we have lots of evidence that when we bring in humans to see if the machines are doing the right thing, they often correct the machine and end up in the wrong, end up doing worse on average. So, how do we think about the role of humans in the healthcare system going forward? There's one which is about helping people navigate stresses and the care and being there. There's another that somebody still needs to design and train the machine. So I think about, with sensors, with every new generation of sensors, we now need humans to figure out how to teach the machine what diagnosis looks like. And so for the very best folks at diagnosis, their abilities are now going to be scaled. And they're going to be scaled not just to all physicians, but to all medical professionals. So look, there is a version of it where we have humans checking the machine at every step. In my view, that sounds like a point solution where all we're doing is what we always did, but a little bit better. And what we've seen so far is that does not motivate widespread adoption, or at least meaningful impact, because like in radiology, we have examples of machines that are just as good as human, or maybe better. But we still need the human radiologist from a regulatory point of view, just because it's not quite good enough as part of the workflow. And adoption has been pretty slow.
No. I'm wondering, like, when so likely, that's what the next 10 years will look like, point solutions. And I think that's starting already in many, healthcare systems, I don't know, that use Epic, and, it's integrated with different AI models, mostly for sort of insurance claims or, authorizations, prior to treatment. But when is that moment, like the Henry Ford factory that you showed, when is the moment that this, when people get out of their boxes and thinking of how healthcare is delivered?
So with past generations of technology, it happens sort of slowly, then all at once, which is you have people building point solutions here and there in various places. You also have established companies, and especially startups, trying things that are totally new. And often the new way of doing something comes from someone who who essentially experimented, realized that, well, now that we have these good language models, now that we have this good diagnosis, predictive diagnosis, that allows us to deliver a different kind of healthcare at scale. And they try to build a company. And with the electricity story I told you, it sounded like it was obvious, right? Oh, we just had to figure that out, and somebody figured it out and it worked. What almost surely happened, there were different startups running experiments, hundreds of different companies, trying new things of how electricity could transform manufacturing. And most of them failed because they guessed wrong. But a couple guessed right, and then everybody else copied. And so what I expect to happen with AI in terms of transforming healthcare is over the next 10 years, we'll see point solutions, but we'll also see large scale experiments. And people trying, well, what deliver healthcare in this new way? So in the chat, I see someone hypothesizing, where, the folks with the might be able to do a lot more, and the physicians get to focus on the more challenging cases. Okay, someone figures out how to make that system happen. They figure out how to make it happen in a particular country or a particular city, and they deploy it. And the way they did it might work, in which case people are going to copy, and that's going to be when the transformation happens. Or the way they try it doesn't work, and we move on, incrementally until someone figures it out. So I think that's how it's going to play out. It's a little less like, it's an explicit recognition of the entrepreneurial risk of doing things that are different.
Yeah.
But I think that's going to be a big part of it.
Yeah. And also there's that point of, and I'm sure many of the audience has, seen the recent launch of the New England Journal of Medicine AI that, really has been sort of started to help the sort of the rigorous assessment evaluation of AI methods and interventions, just like if you had a new therapy or drug. And I think that'll also probably, once we see now real clinical real-world evidence that something is improving outcomes, like, a therapy or a drug does, I think that'll also shift our, how we appreciate AI in the clinical context. Because so many doctors still are, saying, well, show me one case where it's really helped or really changed anything for patients at scale. And it's just hard to do, also in the face of current regulation and so on.
So, no, that's an excellent point, right? If all you're doing is having this recommendation for a doctor, and the doctor's doing everything they always did, then it's not going to have an impact. Like, yeah, they'll catch a few things they didn't catch before, but it won't be that transformative. And frankly, even if it is effective, it'll be annoying to many physicians because the patients will come in with diagnoses that may or may not be correct. They may actually, even in a situation where the patients come in with diagnoses that they figured out through AIs that they have access to, and those diagnoses are correct, and it leads to better patient care, the physicians may not like it. So, it's unsurprising that so many physicians say, give me an example of where this has affected us at scale. I've seen a handful of point solutions that on the operations side have made a really big difference in healthcare. Things like reducing costs, prescription to be part of the physician's work. Many physicians' workflow, they talk into a microphone, and hospitals had departments that transcribed what people said. That's gone. I've seen some hospitals start using predictive modeling for staffing and predictive modeling for predicting when a bed was going to be available. So for discharge, right? And those have been really powerful too, right? If you can predict when a patient is going to leave the hospital, then you can start the paperwork earlier so that when they're ready to leave, you can actually get them out.
Yeah.
So I think there's real opportunities there. And in terms of global health, there it's even more exciting to me. Right now, there's been move toward telemedicine that's been effective, but you still need a doctor. So it's not that, like, to the extent that there's a shortage of doctors, all you're doing is moving that shortage from cities to rural areas to cities. It's not really helping.
Yeah.
But telemedicine type things supported by machine could allow many other medical professionals to provide that kind of care, and that could really be transformative on the edges of where healthcare is currently at its best.
Yeah, that's true. Yeah. So I had one thought during a talk, and that is, who will pay for AI in healthcare?
It depends. It depends what kind of AI and where the benefit is. Okay, so for AI that reduces costs and increases patient health in large, countries with large private healthcare systems, there are real incentives for the insurance industry to pay for it. Okay, we'll see how this plays out, but that's where it starts, right? The insurance industry has reasons to want it, and they have reasons to even do things like provide some assurance on the liability of risk that comes through AI, because it could improve healthcare. In countries with large single payers, where healthcare is largely public, then there's incentives for the public payer to cover it, to the extent that what it's doing is making things more efficient. Who knows on the incentives there about patient health in the long run, but it sort of depends on how you think about the incentives in the public system. But there might be a little less risk taking, just generally given the nature of public systems. For AIs that allow you to diagnose at scale things that you have treatments for, that sounds like good for the pharmaceutical industry, right? If you have a treatment and the big bottleneck to treatment is you're not finding the people who need that treatment at scale and effectively, well, a good diagnosis tool that allows you to do that, you now have real incentives. Then there's going to be some where there's a market failure, where you do need nonprofits and NGOs and public organizations to fund it, because it's not that there's a clear commercial incentive, but it actually is just going to make global health better.
All right, Avi, we're nearly at the hour, and I'd like to close the talk. And Avi and I will now transition also to the neural network, so we can keep chatting there. Avi, thanks again for this fantastic talk, and really got me thinking on many areas in my own practice in the hospital. And what really sticks with me is the example of the company of electricity, and how it just takes its time until we move beyond point solutions to really at some point asking ourselves, how could we ever have done this differently 10 years ago? So I'm really looking forward to that and to experience that also in my career, and I'm sure that many others do so at the same time. And last but not least, obviously, the potential for global public health, I think, is tremendous. The shortage of healthcare professionals, and it's really exciting to see what's going to happen in that space.
My pleasure. Okay, we'll transition over to the neural net. Take care.
Okay, thanks everyone. Goodbye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.